I prepared a little demo where we can see how easy it is to use distributed upgrade and what actually happens underneath the hood. I have a directory where I create a configuration file, a 12.2 to 19c upgrade, and I enable distributed upgrade. Nothing fancy there. Then I use auto upgrade to run an analysis of the container database. 1 CDB, 10 PDBs. Let's look at the summary report. All good. We can just go ahead with the upgrade. My system is a 32-core system, so it's pretty powerful. And as we saw from the analysis, we have a container database with 10 PDBs. Let's do a count on $GB instance to see how many nodes we have in this cluster. 2 nodes. Okay, so it's a 2-node rack system. So let's go ahead and run auto upgrade in deploy mode. Let's start the upgrade. LSJ, creating a restore point. And then I'll use the status command to get some more details. Okay, we're creating the GRP. That's one of the first phases in the operation. I can use the hwinfo command. Very nice command here. See, 32 cores. Now we are in the pre-checks phase and pre-fix-ups phase. So we're preparing the database for upgrade. Drain phase, so this is right before the upgrade actually starts on $cdb$root. I'll use the status command and set it to refresh every 60 seconds. A little later today, we will show you this new cool console command. Mike has a demo on it. And now $cdb$root is upgraded and we are in the post fix-ups phase. Post upgrade, and very shortly auto upgrade is now processing all the PDBs using the 2 nodes in the rack cluster. It has distributed all the PDBs onto the 2 nodes in the cluster. So let's see what's actually happening on node 2. I find all the auto upgrade processes, and here we have auto upgrade. We're using a directory underneath Oracle Base as a working directory. And this is the special mode that auto upgrade respawns itself in. This is what allows the use of distributed upgrade. And this is the special configuration file that auto upgrade created itself based on your configuration file. So let's have a look. And you can recognize the pattern here. We have multiple batches, and batch 2 is assigned to the node AU2, which is the node that we are currently working on. And as you can see, the set of PDBs that are scheduled to run on this node is also being upgraded. We can see that from the call to the db upgrade script that works on each of the PDBs. Going back to node 1, we can see that the upgrades are still well underway. Post fix-ups are also happening distributed. So it's not only the upgrade, also the post fix-ups. And then eventually the upgrade completes. All is good. So very easy to enable distributed upgrade. And there is potentially a very big gain from using not only proactive fix-ups, but also distributed upgrade. We did a benchmark on a 2-node system with 4 CPUs. The blue column are the standard rack upgrades that auto upgrade has been able to do for many years. This is how we used to upgrade rack databases. If you enable proactive fix-ups that we talked about a little earlier, there is a gain. You can see that from the red columns, they are smaller than the blue columns, meaning that the upgrades complete faster with proactive fix-ups. But the huge benefit actually comes from distributed upgrade, which is the yellow column. It is much smaller than the red and the blue column. So our benchmark shows that there is a huge gain from using distributed upgrade when you're upgrading container databases on RAC systems. The more nodes you have in your RAC cluster, the bigger benefit that there will be. If your RAC system is just doing this specific database upgrade, you can utilize all the nodes in your RAC system to get them a fastest upgrade. But if you have other things running on your RAC system, you might not want to use all the nodes in your cluster. And for that purpose, you can specify how many nodes of the cluster you want to use. Imagine I have an 8-node RAC system, but I only want to use 3 nodes for this specific upgrade. Well, I can use the active node limit parameter for the tune setting and set it to 3. That way, auto upgrade will only use 3 of the nodes to perform this upgrade.